Hi students, go ahead and get out your chemistry notebook so you can take some brief notes on polyatomic ions. Now think about that term, polyatomic ions. What do you think these are? Break that word down into its component parts. If you said anything like an ion with many atoms, you are exactly right. Poly means many, atomic, of course that references atoms, so many atoms, but also ions, so things that have a charge. So specifically, what are they? Well, they are covalent molecules, meaning non-metals that are bonded together through covalent bonds, but they have an overall charge. So some examples would be sulfate, ammonium ion, and carbonate. All right, so here you can see sulfate, that is made up of sulfur and oxygen atoms, and it has an overall 2- charge. Ammonium is made of nitrogen and hydrogen with an overall 1+ charge, and carbonate is CO3 with an overall 2- charge. All right, so what exactly do we mean by overall charge? Well, think of the entire polyatomic ion, all of the atoms in it, as possessing that charge. So sometimes this is represented in Lewis structures with brackets. So here's phosphate, PO4. So here we have phosphorus with 4 oxygens. And then the whole entire polyatomic ion is put in brackets, and then that has a 3- charge. You can kind of think of these as like parentheses in math, where you would distribute a coefficient in through multiplication. All right, so here is sulfate, SO4, 2-. That's a sulfur with 4 oxygens. Notice here we have something that goes beyond our octet rule. And overall, this has a 2- charge. All right, ammonium ion, that is NH4 1+. So all of this together, all 5 of these atoms, will overall have a 1+ charge. So polyatomic ions form ionic bonds. So even though the bonds within the polyatomic ion are covalent bonds, when these are as ions, they will form ionic bonds with other ions. So anything between a cation and an anion, that attraction between opposite charges will create our ionic bonds. So for instance, if I had a sodium cation, sodium 1+, and sulfate, SO4 2-, those could come together to make sodium sulfate. All right, and notice in my ionic compound, I have to balance out my charges. So I need 2 sodium ions to balance out the 2- charge of sulfate, Na2SO4. All right, so let's consider the compound formed between magnesium and phosphate. All right, so when those are bonded together as an ionic compound, this is how we would write it. Mg3 parentheses PO4 and then a subscript 2. So what this actually means is that I have 3 magnesium ions. They each have a 2+ charge, so that contributes overall a 6+ charge. And then I have 2 phosphate ions, each of those having a 3- charge. So altogether that would be 6-. So we have a 6+ and a 6- charge that balances out to be a neutral compound. All right, so notice how this subscript is written. When I have more than one of my polyatomic ions, I have to express that I have 2 of the whole thing. If we just put a 2 after oxygen or we just put a 2 after phosphate, it wouldn't give us the same information. It wouldn't tell us we had 2 of this entire phosphate molecule. So again, kind of treat this polyatomic ion like it's its own unit altogether, and we can represent that with parentheses in the formula. All right, so you have probably heard of a lot of these polyatomic ions. There are many, and you can find tables like this all over the internet. If you don't think you've heard of any, just turn over your shampoo bottle. You will see sulfates, sulfites, hydroxides, all sorts of things. So this chart here separates our polyatomics by their charge. So the anions, or the negative charges, there's a bunch that have 1 minus charge, 2 minus, 3 minus, 4 minus, and even up to 5 minus. And then we have a couple cations, or positively charged ions. So ones you might be familiar with, cyanide, you've probably heard of that, acetate, hydroxide. You've probably heard of carbonate, peroxide, citrate, and you've probably heard of ammonium or something similar. All right, so if we were not having virtual school and all of our assignments being open note, I would require you normally to memorize about 7 of these polyatomic ions. So all I want you to be responsible for this year is just being able to recognize them. So if you see a chemical formula that has a PO4 in it, I want you to think of that as a PO4, the polyatomic ion phosphate. All right, so phosphate, carbonate, sulfate, sulfite, nitrate, and nitrite. So those differ by 1 oxygen. Acetate, hydroxide, cyanide, and then our 2 positive ones, ammonium or hydronium. All right, so make sure you have a list of these in your notes somewhere, or you have a polyatomic ion chart downloaded. I'll upload one to the Google Classroom. All right, so the other thing that you need to consider when working with polyatomic ions is balancing. So when you are balancing, it is easiest, for me personally, to treat my polyatomic ions as 1 unit. All right, so rather than seeing this as lead, nitrogen, and oxygen, I see this as lead nitrate. All right, so notice I see NO3 on the left side of this reaction, and I see NO3 on the right side of this reaction. So as long as we see it in the same form on the reactants and the product side of a reaction, we can treat it as our polyatomic. All right, so here, notice I have 2 nitrate molecules, but on the product side, I only have 1. So if I were to balance this, I would notice that I need 2 nitrates on the product side. That would then double my potassiums. I would need to balance that on the reactant side, and then I'll have 2 iodines, which will also balance over here. All right, so easiest to treat NO3 as 1 unit rather than counting, okay, I've got 6 oxygens over here, 6 over there. That sometimes I think gets really complicated. All right, I'm gonna give you 2 practice problems. One is kind of medium level, and then the last one's a little tricky. All right, what are the missing coefficients? We've got calcium bromide and silver nitrate, which results in silver bromide and calcium nitrate. What are the missing coefficients? All right, here is your second practice problem. We have calcium hydroxide plus phosphoric acid, H3PO4, which goes on to produce calcium phosphate and H2O. Where did that hydroxide ion go? So sometimes when we have hydroxide and we react with some kind of acid, we will produce water. So I think it's easiest to see where the hydroxide ion is by visualizing water as HOH. So you can still kind of see that hydroxide ion. All right, so that might help you balance. So you can see you've got 2 over here. You're going to need to add a couple more over here to balance. All right, go ahead, give this one a try. All right, and check your answers here. And if you had trouble with the second one, that's okay. It certainly is a little harder than some others. We can do it in class. But just make sure you're able to recognize those common ions that I showed on the slide, and you have maybe downloaded a polyatomic ion chart.